Hi guys, welcome to lecture 4. Hope you're all doing well. So in this lecture what we're going to do is we're going to start in our second formal language, and that's first order logic. So more specifically, what we're going to do today is, well, basically this lecture is going to break down into 5 videos. We're going to start off first by talking through the basic syntax of first order logic. Then we're going to get into how to do some practice symbolizations, in particular, talk through symbolizations where we have just one quantifier, and then also how we can think about using paraphrase and quantifier scope to help us with symbolizations. And then we'll build in the last video to talking about cases when we have multiple quantifiers and relational predicates. So this stuff is really the big reason why first order logic was developed. But of course, to get there, we need to talk about how the language works and get a little familiar with how symbolization goes. So that's the plan. And let's get started by talking about, again, the basic syntax of the language. So our first video here, we're going to talk through some notions about terms and predicates. Of course, it's helpful to start to see why we're even really kind of moving beyond TFL. And to draw this out, we can think about this argument. So here's an argument. It's obviously valid, right? Socrates is a human. All humans are mortal, so Socrates is mortal. But if we think about how we would symbolize this argument in TFL, we see a problem. Right? So here we've got our symbolization key, and here we've symbolized each of our premises and our conclusion. But of course, this argument, right, isn't going to work if we just look at TFL. These two sentences don't tautologically entail this sentence because we can just simply assign truth to these two and falsity to this one. So what's important here is that TFL, which is an amazing instrument, just simply doesn't allow us to capture the structure that's relevant to these sentences. This is the kind of best we can do. So TFL doesn't let us capture all the valid arguments. Right? But of course, right, if we had more tools, we could do it. And this is how the argument's going to look in first order logic. So we're going to symbolize our first sentence, right? Note our symbolization key here. We're going to have several new elements. So we're going to have what we'll call predicates. We're going to have names for particular objects, and we'll have a domain. And we're going to talk more about this as we go. I just think it's helpful to sort of see an example right at the beginning. And we're going to symbolize our sentences in a different way, right? And note now this argument is in fact going to be valid. The validity of the argument is going to be captured by our formal language. So this first order logic is going to allow us to capture the missing structure. And it does so by, as we jokingly say, splitting the atom. That is, right, to go back a slide, instead of just these atomic sentences, right, which don't have any structure, we have structured entities. We have subsentential parts which are stitched together in a certain kind of way. So this is the big advantage of first order logic. It's going to have more structure. So what particular structure is it going to have? Well, remember that TFL only really had 3 kinds of symbols. There were atomic sentences, there were connectives, and there were brackets. Here we're going to have 6 kinds of symbols. So our first kind are names. Right? And again, it's helpful just to sort of see all of them. Here we're going to use A through lowercase a through R. Another block of symbols we're going to have are we'll call variables. Now, variables use lowercase letters s through z with one exception. And this is an exception because of the way we're doing things online. We will never use the lowercase v. And this is because we want to reserve the lowercase v to be able to express disjunction. So it'll be all of these except for v. Right? Now, along with these names and variables, we're also going to have predicates. Okay? Predicates will express in FOL with capital letters. We'll have the connectives. These will work just like they did in TFL. We'll have brackets. They'll work just like they did in TFL. And here's the big addition. We're going to have quantifiers. Now we'll talk about what these do and what they are in the second video, but it's helpful just to sort of see, here's every bit of our language. It's going to be a combination of these 6 kinds of symbols: names, variables, predicates, connectives, brackets, and quantifiers. So let's talk through them one by one. So to build up to these ideas of names and variables, it's helpful to have a catch-all term to describe them both. And our catch-all term is going to be, ironically, term. Right? So in English, there are broadly 2 different types of terms. We have singular terms, which are words or phrases that refer to or pick out specific entities. And then there are general terms that refer to or pick out something like kinds or types. So for example, Yobka is a singular term, right? And it picks out my dog Yobka, right? In contrast, dog is a general term that picks out the kind or the type dog. Right? Same thing with Socrates and human, right? Socrates is a singular term. It's a name for that man, right? And then human is a name for the kind of which all of us are instances. I hope all of us are instances, right? So what we're going to look at are just singular terms. And when we think of English, there's broadly 2 types of singular terms. There are proper names and definite descriptions. So proper names pick out specific entities, and they do so without describing them. They're just sort of labels that tag particular individuals. In contrast, definite descriptions pick out particular entities via a description that only that particular entity satisfies. So for example, right, Socrates is a proper name. It picks out a specific entity, right, some particular ancient Greek dude, right? Meanwhile, the teacher of Plato is a definite description that only one object happens to satisfy. It just so happens that it's the exact same object that's picked up by the singular term or the proper name, Socrates. But what's important is we note the different semantic functions here. This is just a tag. There's no real description in it, whereas this is via a particular description. So names in FOL, right, are going to work just like English proper names. That is, right, we're going to express them using lowercase letters a through r. We can have subscripts if needed, right? And their function is going to be to tag particular entities without any ambiguity. That is, each name picks out exactly one thing. Now, note, what this means is we can still have 2 first-order logic names to pick out the same thing, right? So, we might call Nathan and Wildman. Both we would allow as singular terms that pick me out, right? But importantly, no name fails to pick something out. That is, right, if we have a name in first-order logic, we know it's going to refer to something. Right? So one way to put this is there are no empty names, right? No names that don't refer to anything at all. So when we do an FOL symbolization key, it's going to tell us what each first-order logic name picks out, or at least each name that's relevant to what we're doing. So for example, we might assign, little a to Socrates, little j to Yobka, little j1 to Yobka as well, and little n to Nathan. So in all these cases, for our particular symbolization key, right, these proper names, these names, pick out these particular objects and only these objects. Now, in contrast to names, variables, right, we're going to express with lowercase s through z, again, except for the lowercase v, because we want to reserve this to express disjunction. And as before, we can use subscripts if needed. Now, the function of variables is very different. So unlike names, which pick out particular entities, variables function a bit like pronouns in English or in most natural languages. That is, they kind of stand in for names. They give us a way to indicate gaps that we could fill by plugging in a name. So for example, right, I might write something like this, where we've got the variable x, the variable y, x loves y, but y doesn't love x. So what I can do now is start plugging in names here, right, and get sentences that I could then evaluate. So Finn loves Princess Bubblegum, but Princess Bubblegum doesn't love Finn, because Princess Bubblegum loves Marceline the Vampire Queen, as we all know, right? So note, again, the basic idea here is variables, well, they vary. We can allow for them to stand for different things. They don't pick out particular objects. Instead, they kind of represent gaps, right? Pronouns. So when we're constructing a first-order logic symbolization key, you never need to say what particular variables stand for. Right? Because in some sense, a variable stands for kind of every entity. We're going to use them in a very different way. So if you've done any algebra before, you will have come across this sort of use of a variable. So yeah, okay, those are our two basic elements. We've got, at least at this sort of level, we've got names, which denote particular individuals without any ambiguity. And we have variables that function a little bit like pronouns, and we never need to specify what it is they stand for. So to go along with names and variables, we have predicates. Now, predicates in natural languages are basically parts of language that ascribe properties. So for example, if we think about this phrase, so is in the CSAI logic class, or a dog slobbered on. Now these are predicates. That is, in order to get a full sentence, what we would do is we add in some singular term and we'd get a resulting sentence. So Nathan is in the CSAI logic class. A dog slobbered on Amanda. Something like this, right? So again, predicates are these bits of language. They express properties. They hook up with singular terms to form sentences. Right? Now, predicates are going to be super important for first-order logic. And in our symbolization key, we're going to express them with capital letters. We can use subscripts if needed. And we're going to write them like this. So we're going to write, say, capital H is going to express the predicate blank is human. Now it's important we keep the blank because this is indicating where it is that we would fill in a singular term, right? So this is H will give us is human, T will give us blank woke up at 3:30 a.m., and T subscript 1 is going to give us blank is a terminator. Right? So now what we have, right, is two elements. We have these singular terms and variables, right, the names and variables, and we have predicates. And you can sort of see now what we're going to do. We're going to build stuff that looks like sentences by hooking the two up. So this can kind of help us to get a grip on how to build first-order logic sentences. What we're going to do is, as I said, stick together predicates and terms. So we're going to have something like HA, which given our symbolization key, is going to symbolize Socrates is human. Similarly, we could write HX to say X is human. And note importantly in this case, X in this right symbolization, X is a variable and it's not a name. So this is kind of standing in as a pronoun. And we're going to do some things with variables once we get quantifiers, but it's helpful just to see the basic unit. A predicate and a term is our basic unit of FOL. This is our kind of replacement for an atomic sentence. So for example, using our symbolization key, if I wanted to symbolize Yabka woke up at 3:30 a.m., I could take my predicate for woke up at 3:30, I take either one of my names for Yabka, stick them together, and I get capital T lowercase j. So this is a way to symbolize the English sentence Yabka woke up at 3:30. Similarly, these things again will act just like atomic sentences, so I can use my logical connectives to stick them together. So if I wanted to say Yabka and Nathan woke up at 3:30, which has happened many times because Yabka needs to go to the bathroom, so she wakes me up, right? Well, we would take the predicate T in both cases, and we would stick one of the names for Yabka and the name for Nathan, and our conjunction in between to get capital T lowercase j, conjunction, capital T lowercase n. And here's our symbolization for Yabka and Nathan woke up at 3:30. So this is the kind of basic element we're going to be working with. If we can get this sort of structure, the rest is just going to keep building on top of it. So it's helpful to maybe think through a couple cases just to get a feel for this basic idea. So let's use our sample symbolization key and think through a few sentences. So we'll go through these one by one. Feel free to pause the video at each case and see if you can figure out on your own how you would do it. So let's take our first one, right? Yabka woke up at 3:30. Well, right, looking at our symbolization key, we know that this is going to be capital T to express our predicate woke up at 3:30, right? And in fact, we could use either one of these two. We could use J or we could use J subscript 1. Both would work perfectly fine. Good. So how about our second one? Socrates is a Terminator. Dun, 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 right? So what would we do here? Well, again, looking at our symbolization key, we know the predicate for Terminator. We know the name for Socrates. So it's going to be T lowercase, or T1 with lowercase a. Again, A picking out Socrates, and T1 giving the predicate is a Terminator. Good. How about our third one? Nathan and Socrates are human, right? Well, note what we can do is paraphrase this to Nathan is human and Socrates is human. We have our predicate for is human. We have names for Nathan and Socrates, and we know how to express and from TFL. So we're going to have, right, capital H, lowercase n, conjunction, capital H, lowercase a. Nathan's human and Socrates is human. Cool. And then our last one, if Yabka woke up at 3:30 a.m., then Nathan woke up at 3:30 a.m., which is sadly all too true, right? So how would we do this one? Well, just like with TFL, we know how to do if-then. It's going to be our conditional. So it just becomes symbolizing this as our antecedent and symbolizing this as our consequent. We know how to do Yabka woke up at 3:30 a.m. We did it up here. And it's pretty easy to figure out how to do Nathan woke up. It's going to be the same predicate with the name for Nathan. So there we go, right? And note here, we used our other name for Yabka, but both of them pick out the same individual, so either one is perfectly fine. So that gives us at least a little idea as to how to start playing around with these terms, right? In particular names, and stitching them together with predicates. These are going to be the fundamental elements of our FOL sentences. What we're going to do in the next video is talk about our other two parts, right? In particular, we want to talk about quantifiers. So I hope this was useful. Take care, guys, and I'll see you in the second part of this lecture.